Hi, I'm Andrew, and this is day one in the advent of code challenges. Every day there's a new challenge that unlocks, and I'll be going through them and recording my solutions as I try to solve each one. Let's take a look at day one. So the challenge is calorie counting, and we're going to be helping Santa's reindeer find the magical energy that they need to deliver Christmas for presents. Uh, Looks like their favorite snack is a special type of star fruit. It only grows in the jungle, and the elves have brought us on their annual expedition to the grove where the fruit grows. We need to supply enough magical energy to collect 50 stars by December 25th. So there's 25 challenges, and each day there's two parts to each challenge. So you get 1 star for each challenge that you solve, and you have to wait until each day for the new challenges to unlock. So for today, all we're going to have is the first 2 challenges. So it looks like for this one, the jungle is too overgrown and difficult to navigate. The elves' expedition traditionally goes on foot. As our boats approach land, the elves begin taking inventory of their supplies. It looks like consideration is food, so in particular the number of calories that each elf is carrying. That's going to be the puzzle input, is the number of calories. The elves have to take turns writing down the number of calories contained in all the meals and snacks that they're carrying. And there's 1 item per line. Each elf separates their own inventory from the previous elf's inventory by a blank line. So in the inputs, these would be 3 items that the first elf is carrying, and then there's a space, and then the second elf would only be carrying 1 item, and so on. So the elves are finishing their items, calories, and they ended up with the following list. Okay, and there's 5 elves. Or in this example, there's 5 elves. In case the elves get hungry and need extra snacks, they know which elf to ask. So they'd like to know how many calories are being carried by the elf carrying the most calories. In the example above, this is 24,000 calories by the 4th elf. So we should be able to find which elf in the list has the most calories. Okay. So I'm just going to authenticate quick, and then I should be able to get started. Great, so how this works is for each puzzle we get a puzzle input, which is going to be similar to the list example, and we're going to just start coding to get our answer. JetBrains published a template project that I'm using to start my branch from, so that's what my project looks like so far. It's just some utilities for reading files and sort of a format for validating what our input looks like. So what I'm going to do is just paste my input here into day 1 text. I don't know that I need a day 1 test, so I'm just going to delete that. So for day 1, there's 2 parts, part 1 and 2. I have day 1 input. I'm going to just get rid of the test input there. And let's start just making sure that it's working. When I run the project, I should be able to see some output from that list. Looks like there's 2,249 lines. Yep. So what we need to do is just make a list where we split each of these into sections by the new line, and then sum up the amount for each one, and then just find the max value of those sums. Let's see. So what we could do is uh, hmm, there's a few ways we could do it, but just for simplicity's sake, we could take the we'll split the input into elves. So there will be a list of elves, and each list will have a list of numbers. Oh, we have to make it a mutable list so that we can update it. Okay. We're gonna return. We're gonna return a value at some point. It's gonna be elves. Um, max of max by um, some something like this. Let's see. We're returning. Okay, so what we're doing here is checking the elves that have the highest sum of calories, but then we also have to return the answer as a sum. So sum of it. Um, there we go. So elves, let's just rename these a little better. That's not how you spell elf. Okay, sum of calorie. So that's what we're going to check is the calorie of each one. We're going to sum that. All right, so that's kind of the logic that we're going to try to return, but in the meantime, we just need to split out um, this list of elves. So take another look at our data. Okay, so what we could do is um, make a counter or counter. We're going to start it at 0, and so we're going to go through the list, and if we find a number, we're going to add it to the current index of counter to the elves. If it's a new line, we're going to increment the counter. And by the time that loop gets finished, we should have everything in place that we need. So for input, we're going to iterate over that for each. And if it's string, oh, it is string. If it is blank, blank is going to check just if there's any spaces or if there's no characters. So if it's blank, counter is going to increment by 1. And if it's not blank, then elves current index of the counter, we should be able to add maybe this needs to be mutable list as well. Add um, it to int. Let's see what that gives us. I'm going to set a breakpoint here and just see what elves looks like after this runs. Okay, we got it out of bounds. Okay, that's because um, there's no indexes in here yet. So yeah, that means anytime we add a new value, we're going to have to create a new list inside of here. So that makes sense. So we're going to start out with a mutable list of, we'll just instantiate this with a mutable list of int. And then anytime we update the counter, we'll just add a new mutable list of int. Okay, it already knows the type, it should be an int, so we could just skip that. All right, let's debug it again. All right, so now when we get to the end here, we have elves, the logic, um, the number of elves, it says there's 252, so that probably makes sense that there's a line break every 10 values or so, and that kind of looks like it could be consistent. We could double check though, just to make sure we can count how many line breaks were in the input. So if we evaluate the expression, we can look at the input and get a count of how many are blank, and it should be around that 250 mark. Yeah, so 251. So I think our logic is good, it's working. Yeah, that sounds good. We should actually check again that this returns a good number. Okay, so that's saying that the elf with the most calories is 68,802. But what we need actually is to find we need to find which elf in the list that is. So we're kind of like halfway there. Well, no, I don't think we need to know. We just needed to know what the max was, I think. If we go back to the challenge, we just have to return how many total calories is that elf carrying. So, looks like our program is already going to return that. We'll just run this and enter that as our output. Okay, so part 1, 68,802. Let's just check that that was right. Submit. And we're correct. Got 1 gold star. 49 more to go. Okay, I'm going to continue to the part 2 for today. And a lot of the times the part 2 for these puzzles, they'll build off of what the work you've already done, so hopefully I don't have to rewrite too much. So here it says, by the time we've calculated the answer, they've already realized that the elf carrying the most calories might eventually run out of snacks. So to avoid that, the elves would instead like to know the total calories carried by the top 3 elves carrying the most calories. So that way, even if one elf runs out of snacks, they still have 2 backups. So it looks like what I need to do is, instead of maxing by just the most, we have to take the most and then the next 2. Okay, so it shows an example. The 4th elf had 24,000, the 3rd had 11,000, and the 5th had 10,000. So we add those together to get 45,000. Okay, so we still need to get a total number. Now we're just checking the top 3. So how could this get updated? And this is in part 2 now, so I'm just going to start by copying the same logic we had. And then kind of work from there. So do this. Okay. What can I do to update this? We can, okay, so we can actually probably sort by the sum and then just take the first 3. Let's try that. Elves sorted by, so now we have a list, and we could sum it, sum of gallery, spell elf right this time, there we go. So sorted by, so now the very first ones in the list should have the most, and then if I just take first 3 and sum the 3 sums together, sum of sum see, it's I think that's going to take just all the elements. Okay, good. So we could just sum that. Um, cool. Let's check this. And this is going to print our second input down here. Okay, so it says 12,440. I don't think that's right because the elf with the most calories had 68,000. So something isn't quite right. In fact, you know what? That's the problem, is because in the sorted it starts with the smallest. Yeah, let's just take a look here. So val sorted. If we move this logic up here, we can visualize it a bit better in the debugger. I already have an idea of how this is going to work, but I just want to show it. If we look at what that is returning, I think I'm taking the smallest 3 instead of the biggest 3. So sorted is going to be, yeah, let me comment this out so we can see the list. Oh, bug, okay. We'll just make this so it compiles. Okay, now when we debug, we should be able to see the list and how they're sorted ascending, and we want them to be sorted descending. So if we look, 1, yeah, 13, 38, 3, 5, 16. So you can see as they go up, the sum is increasing. So we'll just do sorted descending, sorted by descending. Okay. Now when we run this, it should give us a much bigger number. There it is. So 205,370. Let's check that. And there it is. Got both stars for the first day. So that's it for today. I'll be publishing this code onto my public repo. The link to that should be in the description of this video. But that's it for today. See you on the next one.